video 2.5. Okay, here what I'm going to do is explain an Excel spreadsheet that I've posted onto Dropbox. This is your a sample. Wait, I've labeled it O2 sample.max.likelihood.xls. So this is an Excel spreadsheet. It's what I've done is you should be able to. I think you can see the screen, and what it does is computes the likelihood for the log likelihood for the case for that very simple example that I've given. Remember the case where there's a formateur, there's only 3 countries. In country 1 and in country 3, the formateur was the largest party, and in country 2, it was not. Okay, so in this spreadsheet, first I put the data. Okay, this is X right here, so it's 101. Okay, now you should remember we're going to compute a numerical derivative, and so I put D. Okay, that's going to be how small we, you remember from the last slide. So I set it equal to 0.0001, 1/10,000th. I think that's right. And then I've put in a value of theta. Okay, now theta is our parameter, and so what we want to do is we're going to pick the theta that maximizes the likelihood. Now, first of all, what I did is I put in f, okay, as a function of the x and the theta. So f, if you'll notice, so if b2 equals 1, okay, so if the dependent variable was 1, then the value of f equals a6, and that is this value. Okay, by the way, a little hint. So an Excel, for doing an Excel spreadsheet. If you start copying, you can, there's this function. Notice that little square at the bottom of the cell. If I start, you can use that to copy down to other cells. Okay, notice I've done that. I've copied that same cell. Now, usually if you don't put that $sign there, if instead I just put A6, then when I do the copying, the next cell, it would put in that cell, instead of A6, it would put A7. But I wanted to keep A6 because, okay, no matter where in the which row I'm on. Okay, now meanwhile, for the second row, I notice I want the dependent variable to change. Before, I looked at B2 as the dependent variable. For the next row, I want to look at B3. The next row, I want to put B4. And next row, look at it uses B5 and so on. Now I'm going to delete those. But the key is, if I don't put that $sign, then it changes the row. Okay. And you can also, if you want, if you don't want to, if you're going to make a copy to a different column, you can put, instead of, I put $6, I could put $A, $6, and that tells it when you're copying, don't change either the row or the column. Keep it A6. Okay, so let me delete those. Okay. Now, so we've got f. Okay, from there it's either equal to theta or 1 minus theta. Okay. Next column, I just do the log of f. Okay. And then I told you we're going to do a numerical derivative. And so, well, okay, well, let's see. Here, let me go back. So now I can have log of L of theta, and that just equals the sum of all these columns, of all these terms. Okay. Now, if you recall, so here I'm going to do a numerical derivative, and so I'm going to want L of theta plus D, and then we're going to subtract it minus L of theta. Okay, so now let's do little l of theta plus D, so that's log of big L, theta plus D, and that just equals this one. Now, with that is the sum of f, why did I do, plus D. Why did Oh, I see. Okay, so to compute little l, first I'm going to do f of theta plus d. So I'm just going to, it's going to be the exact same f as before, but wherever I had theta, I add d, and that's that A3. That's d right there. If it's, or if it's the x is 0, I do 1 minus theta minus d. Okay, so this is f of x to the theta plus d. Okay, now be careful. So remember when we did this derivative here, okay, when we do this numerical derivative, I'm going to use red. We had L of theta plus d. We did not do L of theta plus d. That's not the same as this, okay? That red thing is not the same as that, okay? Actually, I think maybe in this spreadsheet it turns out to be the same because everything is linear. But normally it's not, okay? It is so easy to make that mistake. That is just a little small typo in your R program or your Excel spreadsheet. So always remember it's L parentheses theta plus D, right paren, not L left paren theta right paren plus D, right? Don't do that, okay? Okay, so remember that. All right, so now on the screen we got f x theta plus d, so here we have there. Then the next column, I just did log of that. And then, okay, so now I'm going to compute L of theta plus d, and that just equals this term right here. And that is the sum of f2 plus f4. All right, now, the derivative, so I'm going to call it the positive derivative. So derivative of log L, I put a plus. That means I'm looking at, I make d, I want the derivative at theta 0, but I'm going to add d to get the positive derivative. If instead I had subtracted d, that would be the negative derivative. I'm going to come back to that. But I want the positive derivative, so that just looks at L of theta plus d minus L of theta, and that's this, okay? So it is A12 minus A9, all divided by A3, which is D, okay? So that's the derivative. That is our numerical derivative. Okay, and guess what? So we got 6. Now, we got before, remember, we found that theta hat should be about 2/3. Okay, so let's try. Let's see what happens. If I start changing theta, so instead of 0.27, let's make it 0.4, and let's see if that derivative will go down, gets closer to 0. Sure enough, it does. Before it was 6, and now it's 3. Let's try 0.5, 0.5, and sure enough, it does work. Okay. And let's see what happens if we put 0.6666667. If we put 2/3, and sure enough, we get pretty close to 0 derivative of that. Now, let's see if it's here. Okay, yeah, goal seek. Let me show you a trick in Excel. Okay, now let's put theta. Let's go back to, say, 0.3, so we don't know the true theta. And but we can use something called goal seek, which says to find the value of theta that makes that derivative equal to 0. Okay, so here's what we do. So let's see. I think I want to go into cell 17. Okay, A17. So now you do tools, and then do goal seek. And goal seek says set cell, okay, A17, okay, so good, it starts off right. So I want the derivative to equal 0. So I want to set A17 to 0 by changing which cell? The theta, A6. A6, all right. Now, let me move this. Fortunately, this computer's pretty fast. In the old days, when the computers were a little slow, you could see the numbers changing. So I'm going to hit OK. And when I hit OK, hopefully you see these numbers, including theta. That theta should go from 0.3 to 0.667, or something very close to 0.667. So let's see what happens, okay? I'm going to count down 3, 2, 1, 0, and then hit OK. All right, ready? 3. Okay, watch. Oh, darn it. I did it too fast. I accidentally hit it. Hopefully you saw that, okay? If not, you know what? I'm going to do it again. I'm going to do it okay real fast. So let's try 0.25. Let's see. So theta equals 2.25. Let's go to log theta. I'm going to do tools, goal seek. Say set cell derivative of log theta. No, that's not the one I want. I want A17. Okay, so tools, goal seek, set cell A17, the derivative, equal to 0 by changing cell A6. All right, I'm going to hit OK. Ready? 3, 2, 1, 0. Okay, there. Sure enough. Got pretty close. Okay, scientific notation, derivative of that is pretty close to 0. And it said theta is 0.66666. Not quite 2/3, but close enough. Okay, so that's one thing you can do. You can use goal seek to compute an estimate of our maximum likelihood function. Okay, another way you could have done it to find the maximum likelihood value, you could have just experimented with theta on your own. Try 0.01, then 0.02, 0.03. Sometimes it's called a grid search, where you just try different values of theta. And then the other thing you could do is try just plug your own values of theta, keep looking at the derivative of the log. When I say that 0.01, 0.02, you might look at log theta, see which one, keep doing that until you get the maximum of log theta. Okay, so that is a way, that's how you can get an estimate of theta hat, okay? Just you use one of those various techniques to get the value of theta that maximizes the log of the likelihood, okay? Now, but we also wanted the second derivative, and we wanted the second derivative in order to get an estimate of the variance of our theta, okay? Now, to get a value of the second derivative, here's what we're going to do, okay? So I told you, I said, what this is, the slope of this line is the positive derivative. That's the slope between that point and that point when we add d to L of theta 0. Now, we could have done it the other way, and we could have taken the negative derivative, the slope from here to there. Now, the way I've drawn it, the slope of that red line and that red line, you know what, let's see. Let me make it blue. Actually, so that's blue. Okay, the slope of that blue line looks like it's about the same as the slope of that red line. But if d had been a little bit bigger, they would be a little bit more off. And if we calculated it enough, as long as that line, that function line, is not linear, the slope of the red line should be a little bit different from the slope of the blue line. Now, the way we calculate the slope of the blue line is it's a function that looks like that, but not quite. It's going to equal L of theta minus L of theta minus d, all divided by d. Okay, so that is the slope of the blue line. This is the slope of the red line. If we took this, so this is the derivative, and that's the derivative when d is a little smaller. If we took this derivative, this term, minus this term, and then divided by d, then that's going to give us the second derivative. Okay? So that is what I have done right here. So I've next taken the derivative of the negative derivative, the derivative of the slope of that blue line, and that's what that is. No. It's this one. So it just equals A9 minus A21. A9 minus A21, this cell, all divided by D. Okay, then to get the second derivative, I've just taken the positive derivative minus the negative derivative and divided it by D, and that's what is here. It is A17 minus A24 all divided by D, which is A3. So that is the second derivative. And sure enough, you remember from our example, we calculated that that derivative was negative 13.5 when we did it by hand. And sure enough, when we get theta is pretty close to 2/3, we get the derivatives negative 13.49, something very close. Okay, so then remember, did I do it in the spreadsheet? No, I didn't, but it's up to you. So if you wanted to do statistical tests, what you're going to have to do is remember to take the negative of that value and then take 1 over that, and that will give you the variance. Okay, so it's going to be the variance is going to be 1 over 13.5, and then we want the standard error, you're going to take the square root of that. Okay, so that is the sample likelihood function. Okay, I want you to use this for your homework as your template. Now remember, you're going to have to change it when you do your homework problem, but make sure you understand this. So I did that toy problem, very simple problem. We calculated by hand the derivative and second derivative, found the theta hat that maximizes. We could do the same thing by doing numerical derivatives. We could have done it in this spreadsheet. Okay, so I want you to play around with different values, maybe increase the size of the data, add some new numbers, make sure you understand how this is working, and get familiar with that, and then pretty soon you'll be creating your own in a homework problem. Okay, so that is 2.5. I think I got the number right, 2.5. Okay, so I'll see you in lecture 2.6.